Hello dear friends, welcome to I Am Civil Engineer YouTube channel. We will see cover for reinforcement in this video. You can read news in newspapers sometimes that the slab got collapsed in some old structures. It may be of some government building or some schools or any other buildings which is of little age. Why it is happening? What is the reason behind it? Those things we will be discussing in this video. You can see a picture here also. The bottom portion of the slab is collapsed like this. So it will be a very unsafe situation when the building is like this. Suddenly this roof will collapse. That means the bottom portion of the roof will collapse and it will fall without any warning. This is an unsafe situation. As an engineer, the building which he is constructing, it must be safe, reliable and durable. The safety is the first point an engineer must ensure. So for the safety, the building must be designed in a proper way. For designing the building, an engineer must understand what is the structure. So according to the gravity load, the beam will be bending in the sagging wise. Here you can see in this picture, the rose color, green color and yellow color strips are given. If you imagine this as a beam, for gravity loading, the yellow color is expanding outside, where in this yellow color region, you will find tension. In this pink color region, you can find that materials are compressed inwards. So here the compressive stress is more. Therefore, for a gravity loading in a beam, the bottommost side will be having tension and the top zone will be having compression. In between, you can find the green zone where the stresses are minimum and the stresses will get nullified in this zone. So this is called the neutral axis. You can see this in this 3D view also. The top purple color is the compressive zone, bottom yellow color is the tension zone and middle green color is the neutral axis zone where the stresses are very minimum. As an engineering design, a beam to be designed for compressive force by using the material concrete and the beam to be balanced for tension force using the material which is very good in tension. So that material is the reinforcement, that means steel reinforcements. This steel reinforcement must be placed at a distance at the extreme end of the beam. So we can take this cross section. The reinforcement must be placed at the extreme end of the beam in the bottom zone so that the tension force is nullified. When we do so, the reinforcements are having a threat that it will be exposed and rusting will happen. Instead of going for placing the reinforcement at the extreme fiber, we have to place at some distance away from the extreme fiber so that enough concrete is embedded and the reinforcement is not exposed for the rusting. So if you take this beam and you can have a microscopic view, you can find that the water will percolate from the very nearest spot of the concrete. That means when the distance is very less here, concrete will deteriorate in its edge and some water particles may enter into this. This condition can be seen in this picture also. Here you can see that the reinforcement is placed in the beam bottom. The beam is viewed from this view. So this picture shows the beam's bottom only. Here the reinforcement is placed without any concrete embedment. That means maybe little amount of concrete is embedding this reinforcement. By which what happens is the water percolates and this full dia circle reinforcement bar gets deteriorated and rusted, and when time goes on, this rust will accumulate at the outer surface of the bar. So what happens is the core area only takes the load and the outer area doesn't takes the load because it is rusted. By rusting, what happens is the round circle bar gets bulged and the concrete portion near it gets much compressive force because this bar is getting bulged. So that what happens is the concrete region surrounding this reinforcement bar gets additional stress due to the compressive force which is generated by this rusting. So what happens is this compressive force get balanced at top because here more concrete is there. But other places in this sideways, if you can see is this concrete, it will get bulged like this. At some point of time what will happen is where the stresses are very more will be where the concrete area is very less. So there will be a chance of cracking of the place where stresses are very more. So what happens is the concrete will spall like this because at this place what happens is the concrete area is very less. So here cracks will develop and the concrete will spall down like this. So when the concrete is spalling like this, it is not like a very small material. It is of 10 or 15 kgs of weight. When it is falling from an height of 3 meters, what will happen is it is much enough to kill a person. So an engineer must be very clean and he must be very careful in giving the provision for cover. So the cover only gives the reinforcement protection from rusting. I have shown the covers here. The covers are of 20 mm, 30 mm, 40 mm. Likewise, it is not like that the cover must be given at the bottom portion alone. It must be given in sideways also. Here you can see a picture where the beam is given bottom cover but the side cover is not provided. By which what happens is the side portion will get and the reinforcement bars gets rusted. So the reinforcement bar must be protected in such a way that it is embedded in a very good manner, and also the stresses are balanced so that it is not away from the extreme fiber and it is not towards the neutral axis zone. Therefore, these regions also must be taken care so that the reinforcement bar is kept in such a way that it is properly embedded in the concrete. This is taken care by reading IS 456-2000. An engineer must know that the foundation or the beam or slab must be given minimum so that the reinforcement is kept safe enough inside the concrete. For footing, the cover must be of 50 mm to 75 mm, and for columns it must be of minimum 40 mm. For beams, the cover must be of minimum 20 mm to 40 mm, and for slabs it must be 20 mm to 30 mm. Kindly subscribe to this channel and give your support. Kindly share this video to your friends and relatives, and thank you for watching.